Hi, and welcome to Algebra Examples. I'm Dr. Finch. Today we're going to look at this example where we're finding the limit as x goes to infinity of the square root of x squared plus ax minus the square root of x squared plus bx. One thing that you might notice is that the focus is going to be on this inner stuff right here. So if you don't know much about limits, that's okay. The main thing that we're going to do is a bunch of algebra to make that whole thing in yellow more legible. Now, normally what we do when we're working with limits is we try to plug in the number that we have. Let's see, in this case, our x is going towards infinity and see what happens. So that's the first thing we should always try when we, so speak, plug in, because infinity isn't actually a number. But if we have x goes to infinity, x squared plus ax goes to infinity, no matter what a is. Now, in this case, a and b are just some numbers. We don't know what they are, but we don't need to solve this. This is a generalization. All right, so the first part is going to go to infinity minus an x squared plus bx. That's going to go to infinity. And even though we're taking the square root, it's still going to go to infinity. And infinity minus infinity, we don't know what happens to that, right? It's too obtuse. We need to do some work to figure out what's going on in this limit. All right, so let's start off. I always like to rewrite our limit every time we go through this. And we're going to think about this similarly to the way that we do when we're working with complex numbers. Because you'll notice here we've got this minus sign and we have some square roots and squareds here. Remember, when you have a complex number, you multiply by the conjugate, and we're going to do kind of a similar thing here. We're going to multiply by a fancy one, and our fancy one in this case is going to have x square root of x squared plus ax, and we are going to add instead our square root of x squared plus bx. And to make this a fancy one, the same thing has to be on the bottom, on the denominator, as we see on the numerator. That allows us to just multiply by our fancy one. We haven't actually changed our problem at all. We've just modified things a little bit. All right, now that we do that, you'll notice that we can actually multiply things out. I'm going to put out a big denominator here. I'm going to put uh, our denominator is just going to pop over. We're not going to worry about that at all. We'll just move that over, and then we are going to multiply everything out. And we're going to do this just kind of a slow method so that we can make sure that we get everything. So we've got square root of x squared times ax times square root of x squared times ax. So that thing is going to be squared. And then plus square root of x squared plus ax, square root of x squared plus bx. Next up, we take our second term and we're going to multiply that through. So now notice we have a minus square root x squared plus bx, square root x squared plus ax, and minus square root of x squared plus bx, and we have two copies of that, so that is squared. Ooh, that does not look pretty at all, but it's going to get a little cleaner in just a second here. Notice on our inner terms here, these two terms here are going to cancel out because they're the same exact thing, except for one is plus and one is minus, which makes our lives a lot better. Next thing that we're going to do is we're going to notice that when we square and square root something, those two cancel each other out. So we end up with x squared plus ax minus, and I'm going to put this whole thing in parentheses, x squared plus bx, all over our denominator. Now, the reason why I put that in parentheses is so that we can distribute that negative sign. This is one of those things that as a student of math, you really should keep in mind. It is important to keep parentheses in until you need to take them out because it is so easy to get little things like a negative sign lost. And once you lose that, oh, it just makes your problem that much tougher to solve. All right, so our x squareds are going to cancel. And what we end up with is a limit as x goes to infinity of ax minus bx all over square root x squared plus ax plus square root of x squared plus bx. Now, this looks a lot better, but it still looks pretty crummy, right? If we tried to plug in infinity, so to speak, you'd get infinity minus infinity divided by infinity. And again, it'd be like, well, who knows what happens to that? So we need to do a little bit more work here. And what we're going to do is notice we have an x in both terms in our numerator. So let's pull that x out of our numerator. We can pull that out and we end up with an a minus b. Oops, our x is out front now. You can distribute that back in to find out that that's going to be there. The next thing that we could do is in our denominator, and I am going to do this in two steps so that we see how this works. X squared is really 1 times x squared, and a times x, we can actually multiply by another fancy one. Fancy ones are our best friend when it comes to these types of problems. Bx times x over x, because they allow us, you'll notice here, we can pull together our x times x on our denominator in both terms. And we're just going to yank out that x squared on both sides there. Okay, so let's actually do this. I am just going to copy and paste this to the next page. Come on. Okay, there we go, so that we can continue working. We're going to take our limit as x goes to infinity, x a minus b. And then we're going to pull out our x squared. We're going to be left with 1 plus a over x. And that whole thing is square rooted. Same thing for our second term. And because we have multiplication in our denominator there, in each of those terms, we can actually separate that square root. Remember, square roots do not break over addition. So like, since I have the square root of 1 plus a over x, that's not going to be the same as square root of 1 plus square root of a over square root of x. It's just not the way it works, unfortunately. But we can break it up over multiplication because it's basically an exponent. And exponents are very beautiful that way. Now, oops, that should be a minus. Now, square root and squared, those are going to cancel. So we have an x square root of 1 plus a over x plus x square root 1 plus b over x. And I know this is a lot of writing, and each step I'm just doing just a little bit. And it may drive you a bit nuts and you want to go faster, and that is okay. The reason why I do this in such slow steps is so that if a mistake happens, I can go back and find it very easily because every single step is written out there. This means that when your teacher's going through your work, they can also see where the mistake happened and what happened. Whereas if you do three steps at once, it may not be clear what went wrong. Okay, so now our x cancels and we get a minus b divided by the square root of 1 plus a over x plus the square root of 1 plus b over x. And if you'll recall, our graph is just 1 over x looks like this, a rough estimate. And as x goes to infinity, we see our graph gets closer and closer to 0. Now we can take this numerator and turn it to a over x or b over x. It doesn't matter what number you put up there, that number is fixed. So your graph is still going to go towards 0, which means when we plug in infinity for x now, a over x and b over x both go towards 0, which allows us to actually get our solution, a minus b over square root of 1 plus square root of 1, which is a minus b over 1 plus 1, which is a minus b over 2. And that is not a solution that probably looked possible when we started this problem. So good luck with the algebra. Have fun with it. And I hope you enjoyed listening. Thank you so much.